Okay, so now let us continue the lesson. I want to teach you a little bit more about functions here. Let us start with a warm-up problem as we had before. So example, I would say, for example, let f be a function such that f of let me make it first very simple. F of minus x is 5x plus 1. Okay, determine f of x. Yes, that's a very simple problem, but my intention is to teach you something to be faster. So I know a function f, when applied on negative x as the input, it gives you 5 times x plus 1. Now I want to see that if the same f acts on x, what will be the result? Okay, so what is the result, do you think? Yes, Tim? Yes. So that is the best way to, so the answer is simply, the answer is this. F of x, but I want you to understand this method, is minus 5x plus 1. Okay, first of all, let me solve the problem as we learned yesterday. So here, if you want to calculate, if you want to determine the function f of x, if f of something else is given to you, one way is to name the new variable minus x to introduce a new variable for that expression inside f. Okay, and then try to find the old variable in terms of your new introduced variable. So here x becomes negative x if I multiply both sides by a negative sign. And then what I'm supposed to do, I need to put them back here in this equation. So now I rewrite the same equation, but instead of negative x, I put capital X. And then on the right hand side, I have 5. And instead of x, I will write minus capital X. And then I will have plus 1. And if I want to simplify that a little bit, it becomes f of x equals to minus 5x plus 1. This is the answer that you get. Of course, that is correct. But if I ask you what is the role of f, you would say it multiplies the input by minus 5 and add 1 to it. Yes? And then what I want to do is, in principle, it is better to switch back to the normal variable, to the standard variable. The standard variable that we use for independent variable of a function is not capital X usually, it's just a little x. So it is preferable to switch back to this old variable by replacing capital X with x. This is something that I want you to understand. Be quiet, please. Thank you. Hello. Hello. Okay. So here, that is the answer. But in this special case, you really don't need to do this so lengthy. In principle, this function applies on any variable. This minus x gives you this. What I want you to understand that this is also a valid way of solving the problem. So what I do, I want to make this x. So I will, in my head, replace x with minus x. Okay? So it means that wherever I see minus x, I replace it with x. Okay? And then what happens? This becomes f of x. But here I do not see minus x, but I can simply write it as minus 5x. You see, if I change x to minus x, this one becomes x, this one becomes minus x. This is a faster way of solving the problem. And I want you to understand this is valid. Yes? So this equation holds for every number x that you put in. So you can change x, for example, to a number minus a. No one will criticize you, yes? Because this formula holds for whatever you choose for x. I will choose minus a for x. Then what will happen? This becomes a, and then this becomes minus 5a plus 1. Okay, did you listen to me, yes or no? Finished? Okay, so the answer would be f of a becomes minus 5a plus 1. And then again you can replace a with x. These I'm a little bit worried. Do you really understand everything that I am doing is completely valid? I am just replacing variables, give them other names. I want you to understand that when we are dealing with functions, these are possible. And then hopefully you don't get confused to do these kinds of tricks in other parts of the problem. Yes, if I want to solve an equation, if I ask you to solve this equation equals to 7, you are not allowed to replace x with minus x. You have to solve that equation. But when it comes to functions, you have a little bit more freedom if you understand what is going on. So we say that this is valid for every x. So if I switch x with minus x, this will also work. And if I switch x with minus x, this becomes f of x, this becomes negative 5x. So I would say that in this case, I myself prefer to immediately understand that this one gives rise to this. Of course, this method is also doable and you can solve it using this method. But if this expression is complicated, then I will have a little bit of trouble if I want to guess what to do. Then I have to do it systematically. Let me test your understanding once more. Let me ask you this question. Assume that x is not equal to 0. So don't worry about that part. I give you f of 1 over x is equal to 3x. Yes? And now I ask you to calculate f of x. But do it very fast, without these intermediate steps. Of course, this will work and you have to know it. But for this simple case, assuming that x is not 0, and I have this equation, I ask you what is f of x? Yes?
X, 3x to the power of 2.
No. You made a small mistake, I think. The answer is very wrong, but I think your intuition was correct. So what is f of x?
1 over 3.
No?
9x to the power of 2.
No. I thought that this should be simple. So ask yourself, how can I transform 1 over x to x? By replacing x with what?
Oh yeah. Shouldn't it just be 4x?
No. Answer my question. So I want to somehow change 1x to x.
Yeah, 2x times
My
2x.
question is that I should replace this x with what? So that the answer at the end becomes x.
1 over x.
1 over x. Yes? So if I change x to 1 over x, you see this is when you see an equation for a function, it means that this equation is valid for whatever you choose for x, if you choose x in the right domain. So assuming that x is not 0, it means that this equation is not valid for a number, it is valid for all numbers except 0. So if this is valid for x, this is also valid for 1 over x. That I want you to understand. So it means that if this equation is valid for x, this is also valid for 1 over x. I just want you to understand this. And that's a crucial step. You see, I say that this equation is valid for all choices of x except x equal to 0 for the clear reason. It cannot be in the denominator. So if this is correct for x, for every x, it is also correct for 1 over x. Yes? And then, what is another better name for this?
X.
X. So this becomes f. Instead of this, I would write x. On the right-hand side, I will have 3 times 1 over x. That is the answer. I want you to understand these things, but of course, you can do them systematically. So how? If I want to do it systematically, what I'm supposed to do, I would say that, okay, you have given me f of 1 over x to be 3x. The standard method is this. Take this one and give it a new name and try to find the old variable in terms of the new variable. So, if 1 over x is capital X, what is little x? It's 1 over capital X. Agree? And then rewrite this equation, but with new variable instead. So it means that this would be f. Instead of 1 over x, I put capital X. On the right hand side, I have 3. Instead of little x, I put 1 over capital X. Yes? And then I told you that, of course, if you want to, you can work with this. If you want to, but it is common to have little x as the representative for the input. So then, I will replace it with x. That is the function, and that is the answer that I got here faster. Is that clear? Yes or no? Yes? Okay. But I have published 4 videos for you. If you are interested in harder problems, please watch those 4 videos. There are 4 problems with solutions. They are around 17 minutes, not more. Okay, so, but let me now give you a little bit harder problem here. I want to ask you this question. Can you solve this one for me? Example. Let me write it in this way. F of... Let me first of all make it a little bit simple. 3 over 2x minus 1 be equal to 3 plus 5x. For all x not equal to 1/2. And the reason is clear. Because if x equals to 1/2, then 2 times 1/2 is 1, 1 minus 1 is 0, division by 0 is forbidden. Let f of this is that. Then determine f of x. Look, this is one of those problems, even I don't know how to do this simple trick. Because the transformation is not that trivial, yes? The transformation x to 1 over x was simple. The transformation x to minus x was also simple. I cannot imagine immediately what should I replace x with so that this combination becomes x. I don't know. I have to calculate. So in this way, this is why I'm saying that you have to learn this general method, but for these simple cases, don't waste your time. You can just do the trick, yes? So I will pause the video. I want to give you a little bit of time. I think 5 minutes, and then we will solve this problem, okay? Okay, so what the answer is? No one? I think that was your weakness. I remember that last time for the exam there was one question many of you actually failed to answer that one. Do you remember we had something that we are supposed to solve an equation with many variables in it, but we are interested in one of them and we make that one a subject, yes? So that's exactly the same thing here. So if you want to solve that problem, I told you the standard way to do this is to take this one and call it a new variable. So let me call it t, not to get confused, okay? So I would say let this be t, yes? And then pretend that x is your unknown and t is something known. It means that if I ask you in this equation how many variables you see, you say x and t too. But my goal, my subject in this problem is not t. My subject is x. So try to solve this for x. That was, many of you missed that question in the previous exam, yes? So how should I solve it for x? Any way that you can solve it. I'm ready to hear it from you. So assume that this is not t, this is 5, this is 7, it's given. If you want to find x with this one to be 5, what do you do?
Can we start with switching the places of 2x minus 1 and t?
Yes. This is always doable. I think this is very good at this level. You learn this once for all, yes? If I have equality like this is equivalent to saying a times d is equal to b times c. Or if you want, you can interchange these two. Interchange these two, yes? Or if you want, you can interchange these two. So these, and if you want, you can interchange these two. So these are the things that you really need to be very good at it, yes, at this level. So if your teacher from here writes this, that, you shouldn't have any questions regarding them. Is that understandable? And you don't need to memorize, because this is the crucial point. So you see, if I multiply this by that, it becomes again AD. If I multiply this by that, it becomes BC. So that is exactly the same thing. If I multiply AD, BC, BC, AD, you see? So it doesn't matter how I write. So yes, you are right. I would give it in my head a denominator equal to 1, and then what I do, I interchange the role of these two. Yes? So what happens? 3 is there, t goes down, 2x minus 1 goes up, and I really don't need to put 1, so let us keep it like that. So what is what you said? And then it becomes suddenly clear. It's a very, very simple problem. This is a number that you pretend you know, and this is x that you want to find. So what you are supposed to do, you move 1 to the right, and then you have what? 2x. And then you are looking for x. So what I have to do, I have to divide by 2. So x becomes, the first term divided by 2 is 3 over 2t. The second one divided by 2 is 1 over 2. And I hope that you don't have any problems to divide 3 over t by 2, yes? So what I'm supposed to do, I told you before, you will put a 1 here, you multiply the ones that are far away from each other and put it in the numerator, you multiply the ones that are close, and then you put it in the denominator. Yes? Or if you want to do it in a way that you like. But that is my goal. And now everything becomes clear. I go back to my original equation. Yes, I go back to my original equation. Instead of 3 over 2x minus 1, I put t. On the right hand side, I have 3 plus 5, but instead of x, I have to replace it, this one. So this becomes 3 over 2t plus 1 over t. And then I would prefer always to simplify things. So that is always better. So I would write 3, I multiply 5 in, it becomes 15 over 2t. And then it becomes 5 over 2. And then I add them. So what happens? 3 plus 5 over 2 is 11 over 2 plus 15 over 2t. Even though technically you can stop here, but I prefer to go back and write f of x. So what is f of little x then? I replace t with x. So it becomes 11 over 2 plus 15 over 2x, that's it.
Wait, what? Yeah. What? Yeah, you make sure.
Am I right? But you see, it was not that easy to guess. This transformation was not that trivial. If I could guess that transformation, sending x to 3 over 2x plus 1/2, then of course I could solve the problem simpler. But guessing this transformation is not that trivial as before. So we have to find a systematic way to solve the problem, and that is my f of x. Yes or no?
Wait a minute. I'm not sure why this works. Or why?
That is important. If you don't understand, please let me know so that we can discuss. You know?
Or why it works, or why we can just solve for x in the.
No, let me tell you another way. So now that we have the solution, we can use that trick. Yes? When you write this, yes? Assume that I am genius and I could able to guess that before calculations, yes? So this is valid for all possible values of x, including this expression.
Yes.
Yes?
Yes.
So it means that I am allowed to replace x with whatever if x is not equal to 1/2, of course. I can replace that x here. So then what happens, I will do this, instead of x, I put that combination. Yes?
Yeah.
And then on the right hand side, I have to do the same thing. Yes?
Yeah.
But then, just be patient a little bit. If I multiply these two in, it becomes 1/2 times 2, 1. 1 minus 1 cancel. And if I multiply that by that, it becomes f. In the numerator, I have 3. In the denominator, when I multiply these two, it becomes 3 over x.
Yeah.
And then this 3 and 3 are cancelled. 1 over 1 over x is just simply x.
Yeah.
But I was not clever enough to guess this transformation before calculations.
I mean, yeah. I see that it should definitely work here. But
No. Which one you don't understand? Do you agree with this method 100%?
Yes. I completely agree that we could check here that this.
No, I'm not checking. I'm not checking. I can do this in a scratch paper. Don't show my scratch paper to you. And in the exam, I can write that,
Yes.
okay, I do this transformation, and then everything works fine.
I mean, yeah, but why we can always, or why we can find not equation, but how that we can find the 3 over 2x plus 1/2 by just solving for x in the.
Okay, that's exactly what we are doing. Yes.
Yes,
So the question is that, of course, the correct thing is that to put it equal to x, but then it becomes wrong. So it means that if I put it equal to x, then it becomes one equation in x.
No, but it's I'm just not convinced why it worked. Why it happens to work that we. Or, why we can't just solve for x and that it just works.
No, what
That's not clear for me.
we are solving it for x and it works.
Yeah, but I am not convinced why that is.
Okay, I can tell you in this way. So if I give you f of t equals to a complicated relation, and if I ask you f of x, do you feel any problems here? For example,
No.
I give you t plus 2 t squared over 3 minus t.
Yeah.
If I ask you what is f of x,
Yeah, no, that's just.
you can replace 2 with x.
Yeah.
Do you agree with this 100%?
Yes.
That's the whole point. Imagine in this way, I want to solve f of t. I want to find f of t, because if I find f of t, immediately I can find f of x. If you like, you can think in this way. So the reason that this will work, momentarily think that I forget about finding f of x, I put my energy to find f of t. Yes?
Yes.
And then when I find f of t at the end, I can find f of x simply by switching from t. So that's the way, if you like it. I don't know. How should I explain more? So here, I want to give it a name, t, and I want to find f of t, and on the right hand side, I want to have t. Okay? So it is natural to calculate x in terms of t so that I can replace x with t there. and then I have f of t equals to something in terms of t, and I want to find f of x. So I need to switch between t and x. That is one way of understanding.
Det var du som kom på.
Are you convinced or not?
Det var du som inte var
I mean,
But the correct one is this method. So there is no
Yeah.
problems here. You go to a scratch paper, you do some transformations, and when you are fine, you show me this transformation works. It depends how you want to interpret that. But probably the correct way is exactly as before. I want to find a transformation that changes this one to x. But because guessing it in this case was hard, I need to find a way to do that. And the point is that I cannot put it in the x from the beginning, then it becomes an equation, x becomes a number. I want to keep the variable.
oh yeah, I get it now. I get it. It's
Yes? Because if I put x here, then it becomes an equation.
yeah, of course.
X is unknown and I can find it.
Yes, I. Oh yeah, okay. I think it is quick now.
Yeah, think a little bit to see how it goes. Thank you very much.
Just